Hello, this is Alain Guigui from Hewlett Packard. I'm basically 5G architect in the telco business unit, and today I'm going to talk a bit of the on how we transform, in fact, core network with Apache Ignite, and especially focusing on performances and scalability, and how we use, in fact, and how we learn to use Ignite actually to scale our telecom portfolio. Basically, the agenda is going to be very short, a bit of trend to explain you a bit of the business context on when we're scaling to those levels, actually, what is the demand, and try to relate the business to numbers I'm going to talk about. And then talk a bit about the story and the journey we've taken with Apache Ignite a couple of years ago with respect to this scalability aspect. And in 22, we had a good start, and then we started to change a couple of things. I will discuss about this, of course. Then in 24, we reached a different scale, and again, it's going to be interesting to see how Apache Ignite did help us actually to reach those levels, and basically end with what's coming next, basically in our portfolio, and what we intend to do over the next 1 or 2 years, actually. So, in terms of business context, when we look at the mega trend in telcos, especially focusing on the 5G side of the market, what we see actually, and we started to see that because this picture is a bit old, but actually numbers have started to get confirmed, is that we see really a growth of 5G, and especially around the IoT market. And IoT is a very wide domain where you can have multiple kind of devices being connected to networks, from automotives, from gas meters, utilities, robots, and within 5G, there are a couple of use cases actually that are driving, in fact, this growth. And what we observe is that the real 5G, what we call 5G standalone, that you see on this slide, is really ramping up. It is taking shape slowly, but it is really taking shape. And the impact on telco is that compared to their actual systems, it's a major change, right? So it means to them more operations, more activities to set up, in fact, 5G. And as a result of that, for us, HPE, it means that we have to find a way to help those customers, our customers actually, to move from 4G to 5G in this more complex operating environment. And still, it's a telco environment where latency is key. Actually, we are really a real-time solution. So we are talking about 1-2 milliseconds of latency end-to-end for our systems. We're not talking about tens of milliseconds, not seconds, but really milliseconds, right? And when we look at this cellular IoT, the cellular IoT call for scale. And when we talk about scale, basically we talk about very high volume of devices being handled into one single system. We don't talk about the usual scales for operators addressing the consumer market in many countries, except a few ones which are very big, very large. But in the IoT market, what we see is that we really need the bigger scale: 100 million in one single system, 200 million devices in one single system. So that's what we call for HPE super scalability, right? And that's basically what we're trying to target on with our products. And of course, when we look at IoT, there is a consequence of that is subscriptions, or for those kind of IoT devices, are very low. You don't pay for an IoT connected device. Think about your connected watch as an example. You're not inclined to pay $100 to connect a watch per month. You're inclined to pay $1 or $2, right, to connect your watch to a mobile network, as an example, right? In other words, the telcos are really challenged in terms of total cost of ownership. They need to find a way to address, in fact, this market in a very cost-effective way, right? So it's efficient operability with maximum automation and super scale within the minimal footprint. And I'm going to talk a lot about this. It's called efficiency. That's what we call efficiency. It is not, a very good point to be able to scale if we scale inefficiently with massive amount of resources. We need to scale efficiently within a minimal footprint, always, right? So and when we look at the 5G workloads, and because of the telecommunication standards, service-based architecture, cloud-native transformation are a major change for telco. And what we observe as well is that from the standpoint of the database, 5G is a lot more write-intensive for the database versus 4G. So, and then for us, it creates a challenge to remain efficient at scale with a workload that is harder on 5G compared to 4G. And I'm going to explain you how we have used leverage Apache Ignite to start to face and address those kind of challenges. So just as a quick description, if you will, right, the product we're talking about are backend systems that are used as telco databases at large, right? And basic, that's what we call a user data repository or an unstructured data service function that you see named UDSF, right? So we have two kind of client applications for Apache Ignite. And basically, because we are architecting our products into a real cloud native, all of those are running on Kubernetes flavors such as OCP or AKS, etc., right? So we have decomposed, in fact, our product into three layers. There is an ingress control layer that you will find in many cloud native architecture. And because, as I said, we are the service-based architecture, everything is now based on HTTP2. So we need a first layer of load balancing, right? And then there is this second layer of business logic, which are client application to Apache Ignite. And of course, at the very bottom, you have Apache Ignite, which you will recognize on the picture as a kind of distributed data grid. And we are using some key salient properties, such as case safety, to be able to provide some highly available solutions that are able to resist to a set of failures, be it a pod failure, a worker node failure, a physical worker node failure, etc., etc. But the idea is to have three layers where each layer can scale independently. So if we need more, HTTP2 traffic, we scale this layer. If we need more UDR business logic, because there are more, typically the traffic has increased for a given number of subs, we basically scale the UDR, the business logic. If we need more subscriber per se into the system, we also scale, in fact, the Apache Ignite. And in terms of performances, scalability, and efficiency, right? What we know for a fact is that if we want to be able to scale efficiently, there is a very first thing that you need to pay attention to is a proper load balancing across all layers. Because proper load balancing is really the cornerstone of scalability, where we can, as you see on the right picture, in the middle of the picture, where you can see, in fact, all your compute nodes evenly loaded, okay? So basically, typical in telco, we try to load the physical nodes, the servers, typically at 70, 80%, not more. But the idea is to load them evenly everywhere, right? That's what we are looking for. This is the target, right? And what we want absolutely to avoid is basically this, right? It's something where you have not a proper load balancing due to some reasons. Typically, you have some bottlenecks, latency bottlenecks, and you start to see, in fact, a load that is not evenly distributed. There are nodes that are more loaded than others, right? So which means basically a direct impact on latency, because for the more loaded node, the client applications will wait a bit more. And on the other side, there will be computes that will be underutilized actually in the system as a whole, right? And that's exactly what we try to avoid, okay? And guess what? When we started, in fact, this journey on scalability, we started for a given traffic. It was pretty small. We started with 1 million subscribers, which is very small in the telco market, actually. And we started to assess on where we were in the overall telco solution using Apache Ignite. And basically, as I said, target was 20K TPS. Barely it represents 100,000 TPS on the Ignite, on the Apache Ignite side. And typically the workload, you can assume that it's a 50% write, 45% read kind of workload to schematize a bit. But actually in 22, we needed already 10 times more, right? And when we started this journey, actually, we were struggling at 20K TPS on the application side, 100K TPS on the Ignite side. And what you can see on the right side, right, is that we were in a situation that we exactly wanted to avoid, as depicted in the previous slide, something not very well balanced. So when you see the percentage of utilization of the various compute nodes, you can see that some of them were utilized at around 30%, some of them a bit more at 40%. Basically, we're under the correct level of utilization at 70, 80%, and at the same time, really not properly balanced, right? So we started to analyze. And the very first thing that we found actually is that the first major limiting factor was storage IO limits. And those storage IO limits were often reached, actually. There are a couple of reasons for that, and I'm going to talk about that, of course, right? But the net result is that because of this, we were unable to load more the systems, right? So that was the first impact. Okay, and as well, in telco, it's not very uncommon to find shared storages. They can be efficient, but in many private cloud deployments, we find, in fact, shared storages. And as any storage, they have an IO limit. They have an IO capability. And very often we are reaching those limits. And once you have reached the storage limit, then all the stack up to the client application, including Apache Ignite, was stuck. Okay. So that was really a problem to us. And overall, we are not able to use more than 45% of allocated resources, even with the fastest storage available in HPE in 22, which was called HPE Nimble. And then, of course, because of that, because of those, of this evenly balanced system, actually, that you see here, what we could observe, in fact, you start to see some small peaks, okay, in terms of CPU usage, and you start to see some variations. And when we are talking about millisecond latency, those small variations have a direct impact on the end-to-end system latency. So we need something that is basically almost flat, right? And what we are observing essentially two things. One, the checkpoint on Apache Ignite was eating basically latency. Each time there was a checkpoint, or the overall system latency was hit by a wide margin, okay? And because of IO saturation. And we observed also that Ignite nodes were not evenly loaded. So we started to investigate a bit more, right? What were the reasons for that? Was it our software? Was it a misuse of Apache Ignite? Was it a bad tuning of Apache Ignite? So we started really to deep dive into Apache Ignite to see, okay, maybe there is something in Apache Ignite. Maybe there was something in our code. Time to analyze and time to improve, right? So the very first thing is that because we were really IO bottleneck, and especially persistent storage IO bottleneck, we started to look at on the way we were generating in IOs, input outputs. And we started to think with general guiding principles. So first of all, less IOs are better. No IOs are even better. Would there be a way to avoid storage IOs, persistent storage IO? And when we look at the overall design and overall data model on the 5G applications, we started to conclude that basically we're not going at memory speed, but rather going at disk speed. So in other words, we are not using Apache Ignite for what it is, a in-memory first data grid, right? So we started as well to investigate new disk technologies, local storages, etc. But we thought that as a conclusion, the very first thing to do is that we should leverage more Apache Ignite, because when we decided to use Apache Ignite in our product, say, okay, it's a super good data grid, it has very good scalability on paper. And the very first question we ask ourselves is that, did we organize correctly our data? Did we separate in our data model dynamic versus static data? Did we correctly, in fact, design the data model, in terms of caches mostly used versus cardinality, okay? And as well, try to optimize this IO and try to circumvent this IO bottleneck by better designing the data model and select, in fact, what should be persisted versus what should be cached only. Okay, so basically, the very first thing that we looked at is really the overall application data model, our own data model, because it starts from there. Like for any database, if your data model is not properly designed or not 100% effective, you pay the price in terms of scalability. So we started to rethink, in fact, thanks to Ignite flexibility, we started to rethink, in fact, the data model. That's the very first thing we started to do. And of course, Apache Ignite brings a lot more. So typically, we started to think about what are the mostly read data actually in the 5G applications. And we started to think, oh, would there be a way to leverage one additional capability such as near cache into our application? Because as opposed to on every single incoming request from the network, having the possibility to have used in a near cache in the application itself, especially with a massively read workload on this kind of data, we should gain a lot in terms of latency and in terms of overall footprint as well, right? So we started to think about, okay, let's use near cache. Let's reframe the data model, right? So let's separate a bit more dynamic data versus static data. And of course, as we were facing, as well as the rest, Ignite nodes that were not evenly balanced, we started to have a look into the data balancing function, the affinity functions, right? So we started to think about a custom affinity function. In Apache Ignite 8, we still had the possibility to create our own affinity function, what we call a custom affinity function, versus the default affinity function, which is based on highest random weight or rendezvous function, if you prefer, right? And of course, we started also to think about, do we have the right ratio in terms of node versus number of partitions versus balancing? So we started to really deep dive and leverage the various, well, some of the various Apache Ignite capabilities. And of course, it took a couple of months to prototype, to experiment, etc. And then after basically a couple of months of work, first of all, because of the as I said, in the initial state, in end of 22, we were struggling at 20K TPS, end-to-end. Let's say over 242 vCPU. A vCPU is typically a core, an hyper-threaded core in this definition, right? Which was, from our perspective, very inefficient. Here I'm talking about the end-to-end solution, right? And basically, we started to separate the data. So we started to separate in different caches, really using Apache Ignite for what it is, right? So we started to separate dynamic data versus static data, right? And we started to unlock a bit things. That did help us to unlock things. Basically, we started to reach around 48K TPS over 192 vCPU. If you compare, we multiply by 2 the throughput, and we divided by, well, I would say 30% the overall footprint, which was a very good start actually. And say, okay, let's continue, guys. And so we started to use the near cache. And as we matured our understanding of 5G and the way the network was using the network functions were using the database, we started to use near cache. And all of a sudden, that did really unlock basically the overall throughput. And we started to reach 80K TPS on a single system with 192 vCPU. So it's a much better, same footprint as the previous step, but kind of 2.5 times the throughput on the same footprint. And as I said at the beginning, efficiency is really key. It's not only scaling the throughput, it's scaling the throughput within the boundaries of an effective footprint, right? And say, okay, nice, guys, can we do something else? And then in the step 3, what we started to do is we started to develop our own custom affinity function. I'll be back to that. But all in all, with this custom affinity function, we basically reached 235 kTPS on 500 vCPUs, right? So basically, if you compare in terms of efficiency, we've done 10 times more compared to the initial state on five times less footprint overall, right? So meaning that we gain a 5 times, efficiency ratio overall in the solution by using those key Apache Ignite capabilities. And of course, the storage IOs were divided by 10 by better designing, in fact, our data model. So for you guys who are designing solutions on top of Apache Ignite, really pay attention to the way you design your data model versus the usage of this data model. It's very key. And Ignite provides a couple of capabilities, and you can really tremendous performance improvements. And here on this journey, I would say custom affinity functions are great, but there are a bit of difficulties with them, right? It's not so simple to develop your own custom affinity function. I will be back to that in the rest of the presentation, right? And on the left side, what was interesting to us is that the guiding principle of really leveraging Ignite as a true in-memory data grid did pay off, right? Because we observed, in fact, a very good linear scaling of Apache Ignite at around 800 kTPS on the database. Compared to the beginning, we were struggling to reach 100 kTPS in a multi-node deployment, and we were able to basically reach the same throughput on a per node basis. So here we are just talking small deployments with 8 Ignite pods. Not so big, actually. So it can be very efficient, and it can scale very, very linearly. As well, to reach that beyond the data model and beyond the database capabilities, you have also to pay attention to the way you are tuning, in fact, your infrastructure. Here I'm talking to architects that might be part of this audience, hopefully, right? Don't neglect, in fact, the infrastructure optimization aspects such as huge pages, CPU pinnings, node optimizations, to name a few, right? Because they can really help you to unlock, in fact, the performance of Apache Ignite. Storage is one thing, but the way to allocate, in fact, and use the metal or the hardware resources are also very key. It appears to be obvious, but most of the time we tend to forget, in fact, the effect of those accelerators, and they need to be set up correctly. So now, in terms of, as I said at the very beginning, performance is a journey, right? And we think that we still have a lot to learn, actually, to multiply, in fact, both the throughput and efficiency again. And we started to play with a couple of additional parameters, actually. And typically, initially, we started with a default number of partitions. We are using 256 partitions, right? And we wanted to analyze a bit the effect of the number of partitions versus this default number of partition, which is pretty small for an Apache Ignite system, I recognize, right? But then what we started to observe, in fact, is, and that can be seen as counterintuitive, actually, when we started to increase the number of partitions, actually, there is an overhead, actually. The more partitions you have for a given number of nodes, the higher the overhead in terms of managing the partitions is high, okay? And it is not negligible, actually, when we start to move from, let's say, 2,000 to 6,000 partition, you can see that there might be a 35% overhead, right? And this amplifies with the volume of data you manage into your cluster, basically. Because if you look at, for a very small system with 1 million subscribers and I would say 11 million records over 8 nodes, you start to see that you can have a 20% overhead. But when you have a system with 20 million subscribers and basically 200 million records in this 8-node system, you start to see that the overhead can be 35%. So if you think in terms of efficiency, it's not good because you lose, in fact, part of the benefits that you have, accomplished with the former activities. And so we started to deep dive even a bit more and say, okay, let's look at the response time in terms of overhead versus the number of partitions. And we started to observe, in fact, pretty much the same effect, actually. If you look at the the curve, what is interesting is that the more you increase your number of partitions and the higher the overhead is. And again, it amplifies with the volume of data. So you must not neglect this aspect. Overall, when you are an architect designing with an Apache Ignite database as a backend or Datagrid as a backend, you need to really pay attention to the tuning parameters for your deployment, and you need to find, in fact, the right balance between number of partitions, number of node, which is very important. And then I would say that on the response time overhead as well on the in terms versus the number of partitions is also increasing with write operations. Okay, so it's very consistent actually. The good news is that it has pretty much the same effect on the write and read operations. So when you start to have the right ratio, you can see that you may find the right ratio for both read and write operations. And when you have a workload that is basically 50% read and write operations, you start to have pretty much a good setting. And from HPE standpoint, we are not yet at the level where we think we have found the right number of partitions versus the right number of nodes. Because remember that all of this has to be combined with the data model, the data organization, and as well the partitioning or balancing function or affinity function in Ignite words that you're using, right? It's very important to find the right combination of all those dimensions to really retrieve the max out of Apache Ignite. And if you retrieve the max of the Apache Ignite, then your application will be really transformed and benefit, in fact, from those tunings. Like any database, but with Apache Ignite, with my experience in telco databases, it has a tremendous effect. It has an effect that is way higher than with other database. You can really go very, very high in terms of scalability and efficiency if you pay attention, in fact, to those dimensions and aspects. And I think that if I would recommend something to GridGain is that maybe there might be a kind of benchmark or abacus typically that could help to calibrate and find in fact as a kind of template. You have this number of node, this number of resources, we recommend those kind of number of partitions. Of course, there are other dependencies, but kind of initial benchmarks that could help, in fact, developers and architects to tune, in fact, and properly sketch, in fact, the deployment scheme. All right. So as you see, it's still a journey, and it's not the end actually for us. And typically, what's next for us? So we multiply by 10 the throughput, right? On basically 2 times more resources than the initial state, five times better efficiency gain, which is very good. But actually, what we need is again 10 times more footprint and 10 times more throughput. Sorry, meaning that the idea is to have 100 million subs. The idea is to reach systems where we can basically support 2 million TPSs, transactions per second, in a single deployment, right? Which means that for an Apache Ignite system, we need to be able to design, deploy at the right scale with the right footprint, something that should be able to handle 10 million transactions per second under the millisecond time frame. Because remember that in telco, as I said at the beginning, we are working in the real-time world. So end-to-end, 2, 3, 4 milliseconds max, which means 1 millisecond at the database level. So we need to be able to find the right tuning, number of pods, number of nodes, right accelerators, and so on and so forth to reach 10 million Ignite transactions per second on a single cluster in the best footprint possible. And what we think actually is that basically for that, we are eager to embrace, in fact, GridGain 9, right? Because we've seen that it has a new query engine, and basically, because of Ignite 8, we had to really find ways to organize data with this, not always clear this distinction between NoSQL interfaces, key value pair versus SQL versus secondary keys, etc. We had to play around And what we hope is that the new Cura engine can help us, in fact, to simplify the design and to gain better efficiencies. And of course, there is this new storage engine, which we hope will also help us to increase performances. And we started to work with GridGain on the checkpointing aspect. Hopefully, checkpoint will be improved, right? And will help us also to gain performances. We know for a fact that there will be this new fair affinity function as part of GridGain 9. We hope that it's going to be more efficient. In theory, it should be than the rendezvous affinity function, right? To bring us, a better data distribution upfront. Or if it doesn't do the trick, then we may have to also develop a custom affinity function. So for us, it might be good to still have this open capability. Again, I'm just sharing, in fact, how we plan to embrace, in fact, GridGain 9 and what we hope to reach with GridGain 9, right? And maybe potentially go for a compute grid approach, right? So it's very key to keep, in fact, those kind of capabilities as part of GridGain 9. We started to prototype with GridGain 9. We are waiting for it to mature a bit, but the hope is to do a 10 time again, performance improvement. The challenges that we will face, like any database migration, guys, and in telco, it's very key. We will have to migrate millions of lines of code because our products developed on top of Apache Ignite have now, over the years, really reached to maturity. And we are talking about millions of lines of codes with very crisp design to reach those level of performances. So we'll have to find a way to migrate those complex million line of codes. And of course, as we start to have system in productions at scale, we will need to find a way to smoothly migrate, in fact, deployments which are handling tens of millions of subscriber or devices provisioned into deployed systems, right? And so to us, it's going to be a real challenge because as in every data migration, there is always a risk. So we need to be able to roll back at any time, but overall, you need to be able to migrate very smoothly, in fact, those customers so they don't see the difference, just the improvement between the solution with GridGain 8 and the solution with GridGain 9. And I will end with that, guys. Hopefully, you will have a couple of questions, and I'm going to end, in fact, the session for you guys here. Hope it has been interesting. Again, just sharing a real-life experience about how to improve performances thanks to Apache Ignite. Thanks a lot.